There are two different pipe bursting methods, dynamic and static. When dynamic pipe bursting is being applied, a pneumatic hammer or ramming machine is propelled through the old pipe with the assistance of a winch which performs the actual pipe bursting operation, whilst simultaneously pulling in the new pipe size for size, or upsizing of existing pipelines is also possible. A hydraulically driven static pipe bursting rig pushes the quick lock rods up to 200 meters into the internal line of the old pipe. On arrival in the target pit, the bursting tools with the new pipe are connected. While the rods are being pulled back in, the old pipe is fragmented and displaced, and a new pipe of equal or larger pipe diameter is pulled in at the same time. Under favorable conditions, the rods can be pulled back through the rig and simultaneously pushed into the rear-facing mains, ready for the next bursting operation. A highly productive solution. The time needed for the rod string assembly and disassembly for an entire two-way mains replacement length is thus saved. House connections can be installed or replaced directly from out of the pit or the manhole to the interim pit without open trenches. Some sewer lines are made of brittle materials like vitrified clay, concrete or grey cast iron. In such cases, a bursting cone and sleeve is utilized, which shatters the defective pipe into small shards and displaces them into the surrounding soil. Materials which are hard to break, for example steel, ductile cast iron or plastic, are cut open with a cutting or roller blade and pushed apart.
Installation of the pilot tubes on line and grade. The 4-inch pilot tubes are pushed through the ground from the launch to the reception shaft. The leading end of the pilot tube is the angled tip steering head. This head holds the LED illuminated target that is visible through a theodolite, camera, and monitor. The theodolite and digital camera are set on the desired line and grade and positioned to view the target through the center of the pilot tube. The crosshairs of the theodolite are visible on the monitor along with the illuminated target. The operator rotates the steering head as needed to maintain the desired line and grade. By using a computer monitor and digital camera to view the output, the signal can be digitally enhanced, allowing for an extended run. This guidance system has ensured line and grade tolerance of 1/4 inch in distances exceeding 500 feet. The dual-walled pilot tubes provide a means to lubricate the outside of the tubes as they pass through the ground, which reduces the force required to thrust and rotate during installation. Diameter by following the pilot tubes with a reaming head that matches the diameter of the final product pipe. The reaming head and temporary casings and augers are attached to the pilot tubes and advanced by the jacking frame. As the temporary casings advance, they push the pilot tubes into the reception shaft, where they are removed. Spoils are removed and transported by the augers back to the launch shaft and fall into a dirt bucket, which is emptied when full. Step 3 is the installation of the final product pipe. A pipe adapter is installed on the last section of the temporary casings and augers to match the final product pipe. Just as the temporary casings and augers replaced the pilot tubes at the receiving end, the final product pipe pushes the temporary casings and augers into the reception shaft where they are removed. The process is finished when the product pipe reaches the reception shaft.
PIPP is a pipe within a pipe, installed without digging. Resin-saturated, coated felt tubing is inverted or pulled into the existing pipe. Hot water or steam is then circulated throughout the tubing, curing the resin and forming a tight-fitting, jointless, corrosion-resistant pipe within a pipe. Service laterals are then restored using a robotically controlled cutting device.
A skilled driller can direct the course of the drill bit along a pre-planned path over great distances. Different formations, however, require different techniques. In alluvial or soft formations, a jetting assembly uses high-pressure fluid to remove formation while drilling. A drill motor replaces the jetting assembly. Now the hydraulic pressure is used to drive a turbine, which rotates the bit without having to rotate the drill string. This allows the driller to orient the bend and drill in the desired direction. The string is pushed forward or slid, guided by the deflection of the bend. Once this directional adjustment is complete, the drill string can again be rotated. At regular intervals, steering data is gathered and adjustments made.
Large-scale pipe ramming processes in gravelly, bouldery, or unstable ground conditions, we have developed this technology that is unmatched in efficiency of setup and installation, while also having the least impact in terms of noise pollution and effect on the overall environment. The hydro hammer setup consists of 5 primary pieces of equipment: rails for the system to travel on, hydraulic press, hammer support cradle, the IHC S90 hammer, and control shack. The first step in the installation process is the construction of the bore pit. Next, the control shack is installed in an appropriate location. With the control shack in place, the hydraulic press assembly is mounted in the rails. Then the hammer support cradle is placed in the press assembly. Once the press and support cradle are installed, the hammer can be placed in the cradle. The final step is the connection of the hydraulic lines. Once the bore pit is constructed, the hydro hammer can be installed in a matter of a few hours. With the hydro hammer setup complete, pipe installation can begin. The first piece of pipe, outfitted with the appropriate drive shoe, is placed on the rails. The hydro hammer is positioned and begins driving the pipe into the ground. The hammer strikes the pipe with ultra-high energy and is accelerated to tremendous velocities that shear the soil and eliminate skin friction resistance. This decreases soil setup time and allows the pipe to be driven more efficiently. And because soils enter the pipe as it is advanced, ground heaving or settling is minimized and loss of ground causing any voids is eliminated. Once the first piece is driven in, the hydro hammer is retracted, a second piece of pipe is lowered into place and welded. Then the hydro hammer is repositioned and the advancement process continues. This pattern is repeated until the steel casing is entirely in place and the crossing is complete. Next, the hydro hammer assembly is removed and the auger boring machine is placed on the existing rails. The auger rotates into the casing, cleaning out any material inside. Additional sections of auger are added until the entire casing is clean. All equipment is then loaded onto trucks and removed from the site. Currently, this process is suitable for projects involving the installation of steel casing from 36 to 192 inches in diameter with a single drive length of up to 200 meters.